So this basic demo is going to be setting up the YOLO model. You only look once to do object detection on a busy street environment. And we're going to slightly vary this demo from just pure object detection to actually object fidelity detection in the presence of some kind of occlusion. So what we're going to do is we're going to do the object bounding box image segmentation, but we're also going to apply a sort of synthetic fog effect to the image to attempt to see how well YOLO performs in the presence of several different types of synthetic fog. The basic YOLO model we're loading is the 5S model, which comes from this Ultralytics library, and it's loaded through Torch, so we're using PyTorch for this. We could also use TensorFlow, but PyTorch is pretty straightforward for this. So one other thing that I just want to mention is YOLO is usually used for fast image detection. It is a single stage object detection machine learning system. You can actually have a multi-stage system which actually does feature segmentation and then detection. The multi-stage system is better for, it's more complex, but it's better for if you need more precise object detection, and those types of networks and setups are usually used in video analysis post the fact. But if you need real-time detection, YOLO is actually really good at real-time detection, though it's less precise because it's using less processing and less complicated feature segmentation under the hood. So what we're going to do is we set up our fog effect here, which is we're using the CV2 library to add essentially like a washout effect through this add weighted method here to have an increasing intensity of white washout of different levels, and I'll show you how that looks like. But that's essentially synthetic fog. A real fog would be interesting and also like useful for comparison and baselining as well. But this is good for our demonstration. So we want to plot predictions. So that's what we're doing. What I did is I set up a method to do the actual plotting of the different YOLO predictions against the different fog conditions. So that's basically I'll show you how the demo looks like there, but we iterate through all of our results, and I have 4 results for 4 different fog levels that I've set up. So this is my image path. I got something called busy city image. When I show you the results, it's just a snapshot of any street. I could replace it. This is mounted to my Google Drive, so I could replace it with any image, honestly, and then apply the same effect. And so I read the image in, and now I have different fog intensity levels. So I start with 0.6, and then go all the way up to 0.9. And essentially this 0.1, if I was at 1.0, then it would be a completely white image and nothing would be detectable. But at 0.6, 0.7, 0.8, we have the ability to control the amount of foggy occlusion. And so we only want to pick out images that we are sure of. So YOLO is going to try its best to determine those images and then plot those in this loop from the predictions from this plot predictions function that we obtained here. And we apply the fog effect for each before we do the plot predictions, so we can show you how the fog looks on each of the foggy models. So we run this, and this is what the output is. It takes a while to run, so I have this pre-ran already. So as you can see, as the fog intensity increases, we start with 0.6, we go to 0.7, we go to 0.8, and we go to 0.9, and less is being able to be detected, to the point where objects in the background are less likely to be picked out by YOLO given our current setup. And we basically get to the vehicles at some point with that 80% fog intensity, and when we're at the 90% fog intensity, we can only really pick out cars, and any higher, I doubt we could pick out anything. So yeah, that is the basic YOLO model as applied to a foggy environment. Thank you.